Hello everyone, welcome to my channel Vidyarthini's Academy of Computer Science, Learn with Passion. In today's video lecture, we'll be seeing about types of threads, and this is the continuation of my previous video lecture wherein we saw about types of threads in operating system. That is part 1, and this is part 2. Here we'll be seeing about types of threads, that is user level threads and kernel level threads, and difference between user level threads and kernel level threads, and we'll also be seeing about multi-threading models. And before we get started, if you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. We are now in our socials, Facebook and Instagram. I have mentioned the IDs in the description box. Please do follow us in Facebook and Instagram as well. Let's get started. And first let us see about the types of threads, the user level threads and the kernel level threads. Okay, types of threads. Threads are implemented in following two ways: user level threads and kernel level threads. What are user level threads? Threads that are managed by the user. That is, user managed threads are called as user level threads, and kernel level threads are the threads that are managed by the operating system. Operating system managed threads acting on kernel are known as kernel level threads. So this is an operating system core threads which is being used by the kernel. Alright. User level threads. In this case, the thread management kernel is not aware of the existence of the thread. That is, kernel is not aware about the user level threads, and generally user level threads are implemented by the thread library present at the user level. What will be the content of thread library? Thread library will be containing the code for creating and destroying thread, and for passing messages and data between the threads, scheduling the execution, and for saving and restoring the thread context. And generally the application will start with a single thread. Alright. This is a pictorial representation of user level thread. Generally the memory is divided into user space and kernel space, and the processes created in the user space has its own threads which are created with the help of thread libraries. Alright. Now let us see the advantages of using user level thread. Thread switching does not require kernel mode privileges. That is, threads are present at the user space, so it does not require kernel mode privileges. User level threads can run on any operating system. Basically, for example, it is a Java code. It can be run on any operating system, and scheduling can be application specific in user level threads, and user level threads are fast to create and manage when compared to creating kernel level threads. Alright. Disadvantage of using user level thread are, in a typical operating system, most system calls are blocking. That is, when one user level thread is performing blocking operation, then the entire process will be blocked. And the next is multi-threaded application cannot take the advantage of multi-processor. Okay. Next, let us see about the kernel level threads. In this case, thread management is done by the kernel. So kernel takes the complete responsibility of managing the thread, and there is no thread management code in the application area. Kernel threads are supported directly by the operating system. So any application can be programmed to be multi-threaded. So all the threads within application are supported within a single process. One good example for kernel level threads are Windows Solaris threads. Okay. Kernel maintains context information for the process as a whole and for individual threads within the process. So kernel is the one which is managing the process as a whole, and also the threads present in the process. Scheduling by the kernel is done on a thread basis, and kernel performs the following activities, that is thread creation, scheduling and management in the kernel space. And kernel threads are generally slower to create when compared to user threads. That is, kernel threads are generally slower to create and manage than the user level threads. Okay. Now let's see the advantage of using kernel level threads. Kernel can simultaneously schedule multiple threads from the same process on multiple processes. and if one thread in a process is blocked, the kernel can schedule another thread of the same process. Whereas in user level thread, when one thread is performing blocking operation, the entire process will be blocked. But it is not the same in the kernel level threads. Kernel routines themselves can be multi-threaded. Okay. Now let's see the disadvantage of kernel level thread. Kernel level threads are generally slower to create and manage than the user level threads. That is, when compared to user level thread, kernel level threads are slower because it has to be implemented by the operating system, whereas user level threads are created with the thread libraries. Transfer of control from one thread to another within the same process requires mode switch to the kernel, and this is time consuming, whereas the in user level thread the switching between the threads is faster. Here it is time consuming, comparatively it is slow. Okay. The next topic is multi-threading model, that is user level threads must be mapped to the kernel level threads in order to get executed, and how they are getting mapped, that is what we will be seeing in this. Some operating system provides a combined user level thread and kernel level thread facility. One good example is the Solaris for this combined approach. In a combined system, multiple threads within the same application can run in parallel on multiple processes, and a blocking system call need not block the entire process. If we saw in user level threads, when one process is blocked, the entire process will be when one thread is blocked, the entire process will be blocked. That is not the case in this multi-threading model. Okay. Multi-threading models are of three types: many-to-many relationship, many-to-one relationship, one-to-one relationship. We will see each and everything in detail now. Okay. Many-to-many model. The many-to-many model multiplexes any number of user threads onto an equal or a smaller number of kernel threads. The following diagram shows the many-to-many threading model where 6 user level threads are multiplexing with 6 kernel level threads. Okay. And now let's see the diagram. This is the diagram wherein a user space has two processes, each process has 3 threads, and each thread is getting mapped to the threads in the kernel level threads. That is, 6 threads are getting mapped to 6 threads in the user level is getting mapped to 6 kernel level threads. Okay, this is what is many-to-many model. In this model, developer can create as many user threads. If in the user space, the developer can create as many user threads as necessary, and he can get mapped to the corresponding kernel thread, and the corresponding kernel threads can run in parallel on multi-processor machine. Okay, and this model provides the best accuracy on concurrency, that is the correctness of the threads. And when a thread performs a blocking system call, when one thread is blocked, the kernel can schedule another thread for execution. The kernel need not stop the entire process, it can schedule another thread for execution. Okay. Next is many-to-one model, that is many user level thread will be mapped to one kernel level thread. That is what this model is. Many-to-one model maps many user level threads to one kernel level thread. Thread management is done in user space by the thread library. So thread management is done in the user space by the thread library. So what will happen when thread makes a blocking system call, the entire process will be blocked. Since it is managed by the user thread library, so when one thread makes a blocking system call, the entire process will be blocked, and only one thread can access the kernel at a time. So one user thread will be accessing the kernel thread at a time, and so multiple threads are unable to run in parallel on multiprocessor. Okay. So where this type of method will be used, that is many-to-one model will be used if the user thread library are implemented in operating system in such a way that the system does not respond them. So system is not responding to user level thread, then the kernel thread uses the many to one relationship mode. Okay. So now let's see the picture. Here you can see that in user space there are 6 threads and 2 process. So for one process there will be one kernel level thread. So all the threads in one process will be mapped to one kernel level thread, and this is what is the many to one model of multi-threading model. Okay. Next is one-to-one model. There is a one-to-one relationship of user level thread to the kernel level thread, and this model provides more concurrency than many-to-one model. Why? Because the user level thread should have its corresponding kernel level thread, and just because it is having corresponding kernel level thread, it provides more concurrency, and it also allows another thread to run when a thread makes a blocking system call. That is one important point. That is, when one thread is blocked, it allows another thread to perform its activity. So because one user level thread has its kernel level thread, so when this is blocked, it allows another thread to run when a thread makes a blocking activity. It supports multiple threads to execute in parallel on microprocessor. So multiple threads can execute in parallel on microprocessors. So what will be the disadvantage? The disadvantage of this model is that creating user thread requires corresponding kernel thread. So one user thread should have its corresponding kernel level thread. So one good example of this one-to-one relationship model is that OS 2, Windows NT and Windows 20 use one-to-one relationship model. So pictorial representation, that is, here in user space there are two process each has one thread. So one thread is getting mapped to corresponding one thread in the kernel space. Okay. So now let's see the difference between user level and kernel level thread. So far we saw about user level and kernel level thread. We'll see the main difference between user level threads and the kernel level thread. User level threads are faster to create and manage. Why? Because the thread library is present in the user space, so it is faster to create, and it is managed in the user space, so it is easy to manage. Whereas kernel level threads are slower to create and manage because it requires the operating system's help in order to create it. Implementation is by a thread library at the user level, whereas operating system supports creation of kernel level thread, so it is done by the operating system. User level thread is generic and can run on any operating system. So when you write a Java program using Java threads, it can be run on any operating system, whereas kernel level thread is specific to a particular operating system. Multi-threaded application cannot take advantage of multi-processing, whereas kernel routines themselves can be multi-threaded. So multi-threading is possible in kernel level, whereas a multi-threaded application cannot take the advantage of multi-processing in user level threads. So these are the main difference between user level threads and kernel level threads. Okay, and that's all for this session. And next topic will be inter-process communication. And if you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. And I've mentioned our socials, that is Instagram and Facebook ID. Please do follow us in our socials. Thank you.